Understanding webhooks. Webhooks are user-defined HTTP callbacks, often triggered by an event in a web service or application. Think of a webhook as a way for one application to send real-time data or notifications to another. This communication is initiated by the sending application when a specific event occurs, such as a payment being processed, a new file being uploaded, or a user signing up. How webhooks work. At a high level, a webhook works as follows. 1. Event occurs. Something happens in an application, like a payment completion or a comment being added. 2. Trigger. The event triggers the webhook, which is pre-configured to respond to specific actions. 3. HTTP request. The webhook sends an HTTP post request to a predefined URL called the callback URL or webhook endpoint on another server. 4. Data payload. This request contains a payload with details about the event, often in JSON format. 5. Receiving application. The receiving application processes the data and may trigger further actions, like updating a database, sending an email, or notifying a user. Key concepts associated with webhooks. Event. This is the specific action that triggers the webhook. Events can include actions like creating, updating, or deleting a record, or more complex interactions like completing a transaction. Payload. The data sent from the webhook to the receiving endpoint. The payload usually contains detailed information about the event. For example, in an e-commerce application, a webhook triggered by a purchase might send a payload containing details like the product ID, quantity, and customer information. Endpoint. The URL where the webhook's data is sent. This endpoint is often an API in another application that is designed to receive and process the webhook's payload. HTTP post request. Webhooks use HTTP post requests to send data to the endpoint. Post is a common method in HTTP used to send data to a server to create or update a resource. Security. Since webhooks involve sending data between servers over the internet, security is critical. Webhook requests often include a secret key or signature to verify that the request is genuine and comes from a trusted source. Differences between webhooks and APIs. APIs, application programming interfaces, and webhooks are related but serve different purposes. An API typically requires an application to pull or request data from another application at regular intervals. This can be inefficient and delay data transfer. In contrast, webhooks are event-driven, sending data in real time as soon as the event occurs. This makes webhooks more efficient for real-time notifications and updates. Real-life use cases of webhooks. E-commerce. In an online store, when a customer completes a purchase, a webhook can be triggered to notify the inventory management system to update stock levels, send an email confirmation to the customer, and log the transaction in the accounting software. Payment processing. Payment gateways often use webhooks to notify a merchant's system when a payment has been successfully processed. This allows the merchant to automatically fulfill the order without manual intervention. Social media integration. Social media platforms like Twitter or Facebook can use webhooks to notify third-party applications whenever a new post is made or when someone likes a post. This allows those applications to display real-time updates without constantly checking the social media platform for changes. CI/CD pipelines. In software development, continuous integration and continuous deployment (CI/CD) systems can use webhooks to trigger builds or tests automatically when new code is pushed to a repository. Example of a webhook in action. Imagine you have an application that manages customer support tickets. When a new ticket is created, you want the ticket's details to be sent to a Slack channel so your team can respond quickly. 1. Set up webhook. You configure your customer support application to trigger a webhook whenever a new ticket is created. 2. Define endpoint. The webhook is set to send a post request to a specific Slack webhook URL. 3. Send payload. When a customer submits a new ticket, The webhook sends the ticket's details, like ticket ID, customer name, issue description, as a JSON payload to the Slack endpoint. 4. Receive in Slack. Slack processes the payload and posts a message to the designated channel, notifying your support team in real time. Advantages of using webhooks. Real-time updates. Webhooks provide instant notifications, allowing for immediate action based on the event. Unlike polling, which repeatedly checks for changes, webhooks only send data when an event occurs, reducing unnecessary network traffic and processing. Automation. Webhooks can automate workflows across different applications, reducing the need for manual intervention. Scalability. As your application grows, webhooks can easily be integrated with multiple services to handle complex workflows without significant overhead. Security considerations. While webhooks are powerful, they must be secured to prevent unauthorized access. Common practices include HMAC signatures. Webhooks often include a hash signature HMAC in the headers, which can be used to verify the request's authenticity. IP whitelisting, restricting the endpoints to accept requests only from specific IP addresses, helps prevent unauthorized access. Rate limiting, limiting the number of requests an endpoint can receive in a given time frame, prevents abuse and potential denial of service (DOS) attacks. Conclusion. Webhooks are a crucial tool for enabling real-time communication between different applications and services. They are event-driven, efficient, and can significantly enhance the functionality of your application by automating processes and reducing the need for manual input. Whether in e-commerce, payment processing, or software development, webhooks enable seamless integration and interaction across various systems, making them an essential component of modern software architecture.